So before I forget, don't Wednesday is your day off, our spring break replacement, so it's the first of two. So there will be no class on Wednesday, don't forget. So no stream, no Zoom, nothing like that. Um, Hopefully that's sufficient. We'll see. But yeah, no class Wednesday. Other thing, I just got an email that the career fair is coming up. So if you are in the market for an internship or a job, please try to attend that. I don't know what Grand Valley's is like, but I've kind of dropped by various career fairs and they're always at least good for experience. If you have a resume you want me to kind of look over for you and give you feedback, I am more than happy to help you with that. And the reason why I offer that is I used to be a project manager. I used to have to read resumes and hire people. So I can give you what I would look for in a person if you want to do that. Or, if you'd rather not do that, make use of the career center and all that fun stuff. But good resume can take you a lot of the way. Your personality will take you the rest of the way. Usually, if it's kind of a good interview, they're more so looking to see if you're worth working with because a lot of the times it'll be more on the job training that you need. They're more looking to filter out bad teammates, which is why 350 is a nice class. You get that experience of team projects. Okay, so we have career fair coming up. No class Wednesday. So I got the exams graded. They are up in Blackboard. Are you all able to see my feedback for you? And Noah, if you're here, your exams will be coming very soon. You weren't. Okay. I will have to figure that out. Hopefully you can at least see the grade. So maybe it's because I have it hidden. Let me do something really quickly here. Because if I marked you down for anything, I gave you feedback on it. Available. Guess maybe I do this. Because you should be able to get a like a normal homework assignment type of thing. I think there was an option I didn't click. We'll see. I saw the grade and a comment. I could see feedback. I think I bombed mine. If you took the exam serial, then you probably did bomb it because you're not in this class. Not any comments. Oh, okay. So if you did see it, then that's fine. So let me do this. Go back then. So for whatever reason, I can't see what you see, which is why I'm kind of wondering. 3, 8. Yeah. Like I can be a pretend student, but I can't log in as any of you. But if you didn't have any feedback, then you probably didn't need it. I think took this class before and I got an A. We didn't take it with me, so you took it with the wrong person. I'm just kidding. No, that's fine. Um, yeah, so those are up. Honestly, I don't think we. Okay, good. That's good to know. Oh my God, Professor chat's going on off screen. Go away. Okay, thanks, guys. Yeah, I don't, unless if anybody has any pressing questions, everybody did fairly well on it. I don't have any major concerns. Um, this is the kind of test you'd expect from me. And I think, let's see. Oh, so there was one question that I think pretty much everybody had varying answers for, and it was related to the Git versus normal. Git is decentralized, so it is a distributed repository type of system. You will have a central remote server that everybody shares with, but you will have a local repository on your machines. And if you didn't talk about it being distributed, you probably lost points for that because that's really the key difference. Everything else is pretty similar. The terms might be different, commit versus check-in, but distributed was basically what we were looking for there. Do you know what the class average was? I didn't calculate it out, but I think the lows were in the 80s and the highs were, 105 basically. So average was probably in the 90s. I also got all of your extra credit, so thank you for brightening my day a little bit with those. Usually that's, I didn't warn you because I wanted to, see how you all treated that. Those are kind of a fun shining light at the end of the tunnel for exams. At least for me, I had a professor that always did that, and he'd have students like make fun of other faculty in his extra credit, and then he'd put them on his door. So I was nice this time. I haven't decided on any faculty I want to pick on yet with that, but overall, I think it went pretty well. So then, in terms of not to spend too much time on this, but in terms of the next exam, so my exams are not cumulative. So you are done with this material. Everything from here on out will be on the final. So nothing, I'm not going to have you go back and look at old stuff. I always hated it when people did that to me. So I will not do that to you. And Noah, since you're in here, same's going to go for the graphics exam. Alrighty. Otherwise, what we're going to go over today, so you have, hopefully you got the announcement of the homework that's due on Friday, so it's a group assignment. I could be coerced into moving the deadline to Monday. I forgot about the break day. But if you all need a couple of extra days to work on that, I am more than happy to accept that. If somebody decides that they want it, please feel free to drop that into chat. Otherwise, I'll leave it as is. But that would be wonderful. Robot smiley face. Perfect. Okay, we'll do that. I'll move it after class. So, yeah, that's me. Blackboard already says it's due Monday. Does it? Should be due Friday. I'll check after class. I thought I had it set for Friday. Maybe I did make it Monday because I was being nice. But what we'll do is we will have that due Monday, and we'll also do a Zoom session next week for little presentations for your teams to show you where you are. After I update the deadline, I'll also send out a info on that for you all. So you can, have a little bit of a different thing, talk about your projects, hype up what you're working on, all that fun stuff. But we need to get through use cases so that you know what to do for the homework. So we're going to talk about what they are. We will talk about the diagrams themselves. We also have an extended use case diagram, so we'll talk about that, and we'll figure out how to actually capture them. So quick slidey for you all, because I'm curious. Now that we're done with the exam, I'm curious how much did the exam actually take you to finish? So how much time, if you had sat there, I'm going to guess that some of you probably took it spread throughout the day. That would have been a fine exam for an in-person type of thing. 120 minutes plus, really. I'm sorry about that if that's the case. It should only have been an hour, max. So those of you going over an hour, is that because you took extra time to work on it, or was there just that much content for you? And this is more me feeling out, how to do the final exam. Because to me, it shouldn't have taken more than an hour. Hey, another student following. Hello. I'm bad at poetry. I took my time. Okay, that's fair. I did. So your poems and your haikus are all delightful. I will say that. Um, I'll share those probably next class. I'll just have to put them in a nice format for all of you. Okay, yeah. If that's the case, that's fine. Normally, yeah. So that's one of the other things too with an exam like this. You can get into the state of making sure it is perfect. Yeah, okay, that's fair. That's good. Um, my exams at my old university, so our classes were always 2 hours long. When I would do a final or a midterm, usually I would write it, and people would be done within an hour. So usually it's more of a check to make sure everybody knows what's going on. Okay, that's good then. Alrighty, let's talk about use cases. So these are going to be the first UML diagram that we dive into. If you do any kind of UML diagramming in the future, it's either probably going to be class diagrams or it's going to be database diagrams. So if you go into like the database classes, you do the ER diagrams and things of that nature. You'll probably see that. That is actually a form of UML, depending on your environment, obviously. Or you will do use cases. And anything beyond that would be surprising to me. Um, I know a lot of researchers use like architecture diagrams or component diagrams. In industry, I haven't seen it as much, but there are some places which might actually use it, so it's kind of good to get experience with these. But use cases are pretty commonly accepted as kind of low stakes, easy to get up and running, nice diagrams. And again, these are great for communication with possibly non-technical people too. So what is a use case? This is something that is going to capture some sort of function related to your system, and it can be really anything. Honestly, the goal here is to figure out how your user or some entity, could be an automated entity, it could be a script or something like that, but how they interact with a thing. Okay, so basically they're going to be doing X activity. So here are a couple of examples. Let's say that we are writing Microsoft Word, new version, or we're maybe contributing to LibreOffice. One of your use cases is to format a document. Okay, so let's justify it. Let's make the text bold. At a high level, we are formatting it. So this would be a use case. Very, very high level here, right? Or if you're writing an elevator controller, user pushes the button. What is the use case? Request an elevator. So we want this entity to move down to our floor, but the use case is a very high level, bite-sized chunk of activity. Okay, so then a question might be, and again, very ethereal, doing the professorial hand wavy thing. Got some examples here momentarily. Question is how we can figure out what these are. So how do we understand how to write our use cases? How are they elicited? That term should be very familiar to you. So curious to your thoughts. How do we actually capture them? Let's say, and again, this will be fluid depending on your process. Let's say we have our requirement spec. Okay, I'll have Kirby be my requirement spec. Here's my requirements. How do we get the use cases out of him? I moved my little toys down here to help with my graphics class. But survey. Hmm. Hmm. No, if I don't have fun with this, then nobody will, right? Survey, okay. That could be one way. Yep, so that's kind of going the requirements elicitation approach. Any other guesses? This slide do kind of lags at times with responses popping in beta tests. So consider that we probably have the requirements. Beta tests and surveys could be one. We are reaching out to our user base or our customers to get additional information. Or maybe you were taking from what we already know, right? I mean, basically the key here kind of is that we are going to peruse our requirements, We will, let me pop this up here. Make sure I didn't get any extra answers. Come back, Slidey. Okay. Sometimes it's very laggy. So let's say that we have our spec. Functional requirements, non-functionals. We have our surveys. Maybe we're going to do a beta test to get additional features. But we need to actually figure out what we're going to be doing. Okay, so we're going to take our requirements and maybe bubble them up to a higher level. Or you could go the opposite way. We could start with our use cases and get requirements out of them. Just, again, depends on your process. But let's go back to our formatting a document example. So you're working on OpenOffice or LibreOffice. Okay, you're contributing to their public repo. Let's say that you want to format the document. So let's change styles. Create a heading, create a subheading, create a block of code type of text. Maybe you want to copy the style where if I have two documents open and I copy and paste document A, you get the same style in document B, so that formatting, that copy and paste functionality will persist. Okay, so we have options here. These are all high-level things that we have to do. So here we have kind of, these are more so what we're doing when we're formatting the document, right? Very detailed. If you take that and kind of rewrite it as let's just format a document, so that'd be define a style, change a style, or if you want to ensure that the formatting is consistent, that would be, say, copying a style. So this one would be more of a goal. So this is something we want to achieve, and I'm not trying to just like read this here, but basically it is something that we want to do. This one is more of an interaction. So we have interactions, we have goals. And let me just kind of pop open an example here. So here would be a point of sale system. So your typical cash register software. Who is involved with that? You have your cashier, you have your customer, might have an automated, checking system elsewhere that you feed to, but it's not part of our diagram here. What happens? Customer wants to buy an item. Cashier has to log into the system. We might want to refund an item. And again, point of sale systems, there's a lot more activities you can do with that. But this is kind of the scope that we're looking for here. So very high level, very broad. And what we'll do later on is we'll expand on these so that you can get the detail that you need for programming. Okay, but what we're seeing here is actors, so little stick figures. We have our use cases, so they're ellipses with the text inside of them. And then you have your system boundary. Right, so we talked about boundaries before. Here's one place where we can define that. And this is more the boundary of this particular use case diagram. It doesn't have to be the system as a whole, but it's for this particular slice of what we're modeling here. And based on where the lines are, you can see who is interacting with which activity. Okay, so again, high-level diagram, but can be very useful for figuring out what your system has to do. So a bit more detail then, when we have these goals, when we have the interactions, basically what you're looking to do with the use case diagram is that let's figure out our goals. So let's figure out what we want this system to actually perform, what we want it to do, okay? And then figuring out what we're going to do with those goals is the next step. And that's where we go into more of a different diagram. So the interactions are probably going to be more in like an activity or an interaction diagram, separate UML. The goals are going to be the high level. Sorry, I keep leaving that there. Oh my God. I don't need Hangouts on my phone right now. Mute. Some chats happening off screen that are very annoying. Anyway, off topic there. So let's say that we have our goals, right? So ensure consistent formatting, format a document. These are high level. Define a style, change a style, copy a style, interactions, activities we do to ensure the goal is satisfied. Start with the goals, refine into interactions. All right, so basic use case diagram. What do we have here? And I kind of talked about this in terms of the figure, but the actors are going to be external. They're going to interact with the system. So that's stick figure with the line drawn. Use cases are going to be the little ellipses, which talk about some goal. And if we go into more formal detail, these will yield a result. The connections then, these are going to be your lines. Okay, so actor, use case, connection. Makes sense. We'll get into a little bit more detail on these connections too, because we can say have use cases include or extend other use cases. Now, one more thing before I ask you if this all makes sense. A use case, an easy way to think of what they are, they're verbs and then nouns. Something is doing, so basically an activity and then a something. Okay, so action, thing. So evaluate, loan application. Close out, loan. Generate, late notice. Grade, exams. Swing, sword. Pretend it's we're developing a little 2D top-down type of thing. Verb noun. So if you've ever written a PowerShell commandlet, hopefully this is very familiar. If you have no idea what I'm talking about, that's fine. But basically, we're just capturing high-level goals of the system, and we're going to write them in very short, like 2 to 3 word statements. In your use case diagrams that you're doing for your group project, verb, which is some action, and then noun, and that's it. This should not be a sentence. This should not have a great amount of detail. Questions so far? Again, these are basically events that happen. Trying to think. I know some of you are doing a Unity checkers game, right? So display checkerboard. Shouldn't requirements, yes. Yep. So these should all be tied together. So the requirements are going to be very precise, detailed sentences, right? These are high-level visualizations of those. That's why I said you could start with requirements and create these, or you could start with use cases and create your requirements. If I have, so here we have a loan system. Let's go back to this one. Let's say we're writing requirements for a point of sale system. I'm probably going to have 10 to 15 to 20 to 100, depending on how complicated this is, requirements related to buying something. I would have to tie this to all those requirements. Yep. Now, if you're looking at this, these are all pretty simplistic, right? And that's kind of the intent. You want about like 3 to 8 use cases per diagram. Any less and it's not really useful. Any more and it's too complicated. You might be kind of wondering now, what's the point of this? It's to visualize what your system is doing. Use it to talk about what your system is doing with other people. Really, it's great for communication purposes. If I were to give a diagram like this to all of you, let's say, we're developing a point of sale system. I want you all to write me an Android app to, provide this stuff. And then you see, okay, buy item, login, refund. What do I get out of this? I know we have to write code to buy something, which probably has a lot of details behind the scenes, right? Item has to be in the inventory. Item has to have a price. We have to be able to remove it from the inventory later on. Those are details for the requirements. Log in. The customer doesn't log in, so we know that this particular entity should not have access to log in, but the cashier does. Refund. We know that the customer has bought something, so it's probably related to buy item in some way. The customer wants their money back, so we have to be able to scan the item, Cashier has to be able to approve the refund. Money has to go back into the user's account or the customer's account. And then that inventory has to go back into our, inventory management system. These are all details not covered here, but they're all kind of implied by this diagram. And then what would we do? So if you are a high level, project manager, you are a customer, you are somebody maybe with not deep technical input on the project, you'd look at this and say, okay, yep, makes sense. This is exactly what we need to do. You as the programmer are going to look at this and say, okay, buy item. Let's go into a little bit more detail. This is requirements 500 through 601. Let's go look at those and now implement that functionality. And different perspectives will be important here. Questions so far? You will be doing this for your projects. Ooh, hearts. Look at that. So things that happen as well with this kind of a diagram, be sure that you follow the syntax of the diagram. And the syntax, again, is how you draw these things. So entities or actors are stick figures. Okay. If you put something else out here, I'm not sure what that is. Your use cases, these are all ellipses. If you put a hexagon inside of here, that could mean something totally different. In goal diagrams, they are, what are they again? They're entities. They're basically actors in a different type of diagram. The key here is that if I'm expecting to read a UML diagram and I'm thinking, okay, you're submitting a use case diagram, I'm expecting it to look like this, right? Circle or ellipses, rectangular box, stick figures. Anything else doesn't have meaning. And the reason why that's kind of important, for one, is to ensure that everybody knows what you're talking about. Like we are all going into this expecting to know how to read a diagram. But there are also automated tools out there too, where you could say define a use case diagram, plug it into Eclipse, and automatically generate documentation, automatically generate code. So it's kind of useful to be precise with these things. So just make sure you follow the syntax. So one other thing here. So we hopefully know how to set use cases. Excuse me. Again, they sound simple, and they can be, but it's very easy to go with too much detail or too little detail. So finding a nice balance is kind of tricky here. Another thing to do is figure out where the boundary is. So let's say that we have our point of sale system. Again, this boundary is represented by this rectangle here. If I'm, say, looking at it from the customer's perspective, they can only buy the item, they can only refund something. They can't log in here. Whereas if our boundary includes considering other entities, we're going to have other use cases in here. This is kind of the difference, hopefully makes sense. Based on what you are trying to model, set your boundary appropriately. If I were to have a use case in here for login, but nothing tied to it, that would kind of be problematic because it's not a part of the system that we have here. Again, system is kind of a fluid term, right? Just depending on where you're looking at. Might have a big all-encapsulating system, or it might be a smaller subsystem type of thing. Basically, the goal is to set appropriate expectations here. All right. So here is a little bit more of a detailed use case diagram. And we're going to go into, again, a little bit more complicated use case notations as well. And if you don't like my explanation, I've got a nice little Medium article here as well for UML diagrams, basically. UML, use case diagrams. So this is going to be a check-in service for a an airline, something that hopefully we'll all start being able to do fairly soon. So, it looks pretty similar. We have our boundary, we have our actors, we have our use cases. Here, we have a check-in representative, so the person at the gate. You might have customs officials or a destination airport. Again, a little bit of fluidity here in who this particular person is. We have our passengers and we have the people handling the baggage. So there's our 4 actors right there. We can have, again, automated systems. Depending on your notation, I like them as stick figures. I know there are other, let's see if I have any quick examples here. I do not. Okay. I have seen UML diagrams where automated entities are not strictly stick figures, just as a warning. But usually you put like a little bracket system or something like that underneath it. Anyway, how does this work? We have check-in related use cases here and boarding related use cases, and then passenger lists. And 1 second. I swear one of these times I'll learn how to properly public speak without losing my voice. So we have a check-in representative, we have a passenger. Let's look at these ones first. Passenger and the check-in representative are related to checking in, so we have use cases for that. Check-in, automated check-in, express check-in. These are all 3 different flavors of probably very similar tasks, right? Depending on your passenger, they might change. Depending on their status with air miles, it might change. But that's not represented here. All we know as people modeling the system, all we know here is that we have 3 different ways to handle check-in. The particulars of implementation will be elsewhere, like in your requirements, for instance. Then we have boarding. What does it mean to board? Well, you go through the process of, you shouldn't have your baggage at this point, but you go down the tunnel, you get on the plane, you go find your seat. Boarding procedures are performed, plane takes off, everybody's happy. The check-in representative doesn't deal with that, right? You probably have a stewardess or, some other system dealing with that, but we're not modeling them here. But we're kind of seeing, again, who is responsible for what. Now, does the check-in representative care about the passenger list? Does the passenger care about the passenger list? Nope. But customs officials do, people handling your baggage do, so they have access to this particular goal. And you might ask, okay, well, there's different colors here. You said the syntax is very important. In this case, the color is just a style perspective. There's not a meaning to any of these colors here. Different UML modeling tools will have different color schemes as well. And one thing that I need to do now that I'm thinking about it is I need to give you all some modeling tools because I haven't posted those. Note off screen. Because we have a lot of different tools out there. One of them I can show you really quickly here. It used to be called draw.io. It's not draw, it's now diagrams.net. Decide later. So this one kind of has a very Google Drive-y type of interface, but draw.io is now app.diagrams.net. But you have all of your UML diagrams, so I could draw a stick figure. So there's my actor. Here could be my use case boundary. Excuse me. I don't know why I've got dry throat going on today. I don't mean to be coughing on camera. Apologize for that. But very quickly, very easily, I have a diagram, right? And if I want to draw my little, okay, wrong thing. That's the one. Okay. Let's move you down here. This needs to go to the back. Nope. To the back, please. There we go. There's my line. Beautiful. Looks like a massive arm. You can format all this as well. Like it could be just a straight line. There we go. Okay. UML diagrams. For this class, I don't care what software you use. Okay. So you could use Draw.io. You could do it in PowerPoint or slides. You could download a UML modeling tool. We are not going to be plugging it into automated code generators or anything like that. So for me, just the visual is enough. Let's change this to grade exams. Prof. Why is actor still there? Oh. This tool is okay. It's not the best, but it does the job. Basically, you just want some kind of like a vector-based tool where you can, draw lines and have them link up to each other and move around automatically. The reason why is that if I click this and I want to move it down here, arrow moves with you. I don't have to like erase and redraw stuff. Maybe I want to have another UML diagram or another use case diagram. This kind of depends, but a nice little tool will save you a lot of headache. I could do this in Paint, but it would be a massive pain in the butt. I will drop some links in the course information for this, though. So that was one example. Pretty, again, high level, but we're using these for communication and kind of refining what the project does. Another example here introduces a new flavor of syntax, includes and extends. Okay, so we have our basic diagrams, right? So we have something like this, we have something like this. That's probably enough to get you moving with a project. Well, let's say we want to make things a little bit more complicated here. So here we have a point of sale system, but it's for maybe a financial, trading house, so like a Fidelity or a Merrill Lynch or something like that. So here we don't have inventory, we don't have stock, we don't have purchases, we have stock, but stocks. We don't have things in the warehouse, I guess. But we have a lot more going on. So we might have trading managers, traders, salespersons, salespeople, a actual system, like an accounting system. But, we could use the same kind of notions here to make things a little more complicated. So let's take a look at the trader, because we're getting close to the end of class here. So we have some goals to say, analyze risk, set deals, capture deals. So again, specific to this particular system, but, kind of still high level. So let's say analyze risk, figure out price deals. These are things that our traders are doing to trade stocks or to set up mutual funds or, whatever we're doing. We now have, this includes notation. So what does that mean? It's pretty similar to what you understand from your programming languages. So if we have a goal or use case that includes something, we are basically including some of its functionalities. So here we have a valuation. So let's analyze how much something is worth, for instance. If we have to analyze risk, we need this module. If we were going to figure out price deals, we probably need this module. Okay, so we're going to include it. Now, you don't see any actors attached to this, right? So there's no actor link up here, which is fine. But we do have a use for it with this include functionality. We also have extends. So let's say that we want to, we've discovered a deal with our, say we analyzed risk or we found a price deal. We now want to try and capture it. Well, we might have some functionality out there that we need to extend. Okay, so again, very similar to what you might know from other programming languages where you're going to bring in some functionality and then you're going to add to it. You're going to extend it in some way. So I've got some more details here to help you out. And this awfully diagonal line that I probably should just make a straight line one of these days. What is going on off camera here? Oof. So many notifications you forget to mute when you go live. Okay, so includes. Okay. So consider this like a module that you are importing, or you are including a header or something like that, right? It is reusable across multiple functions. I just need to include this thing. Again, we are at a very high level here, right? So we're not doing a direct implementation where include stdio or import um, scikits in Python or something like that, right? It's not a specific thing, but we know we have some module we need to bring in. It's reusable code. So maybe valuation, maybe that's a little bit unclear, but let's say that you have some kind of a sanitization procedure. So you're handling data entry from a user, sanitize inputs, or check authorization that this person is who they say they are, or that they can do what they are able to do. Authentication is who they say they are. Something that you're reusing, okay? Extend then, let me pop all these up, is where we are going to take some existing behavior, some existing use case, and we're going to add on to it. We're going to extend it. All right, so the idea here would basically be to take something else, add a bit onto it. Distinction makes sense, hopefully. So again, if you've done including and extending in other programming languages, Java's pretty good example of that. You can include stuff. You can also do like an extends notation on your classes. So hopefully that's helpful here. We are coming a few more minutes left in class here, so let's take a look then. So if this makes sense, that's pretty much all we need to talk about for the notation of UML, the use case diagram for UML. So we have actors, connections, use cases, boundary. If I wanted to like have an include in here, buy item, refund item, I'd probably have inventory lookup where we could include a use case inventory lookup, something of that nature. So again, depends on the level of detail. If we're good with that, let's talk about the use case extended description and the description and the extended description. So I've been going on and on and on about the beauty and simplicity of these diagrams, and you are all wowed and amazed at how awesome this is and how you're going to go forth and use it every day from here on out forever. Sarcasm, hopefully registered. There's not a lot of detail here, right? And as technical engineers, that's probably not useful for you in your day-to-day life, which is fair. Again, this is more of a visualization tool. We can generate a use case description for each use case, and this will give you that detail that you need. Okay, so let's actually create one for buy item here. So again, we've sat down, we figured out what use cases we need, who's attached to what. Now let's write it down. So we have a template. What is the use case? Buy item. Okay, right there. Who are the actors? We have a customer and a cashier. And we can even get a little bit more detail here. Who is initiating the use case? Who's triggering it? In this case, it's the customer. They bring you an item, they want to buy it. They're starting it off. Then you have a short text prose description. Customer arrives at the checkout with items to purchase. Cashier records the purchase and collects a payment. On completion, the customer leaves with the items. More detail. Not quite the technical writing level of a requirement, right? If these were requirements, we would break them out into individual sentences. We'd use our shell notation, all that fun stuff. But we know exactly what this use case is doing. There's little to no ambiguity here. Right, so use case diagram, use case description. we can then expand our use case description where this would be something that I would expect every use case to have. You only are gonna think in the homework, you only have to do one, but this is what is going to be most useful for you in a real world project. Okay, so we have our use case diagram. Let's create a expanded description. So use case, actors, description, that stays the same. It's describing what this use case is, but let's cross-reference it. And this is that whole traceability thing I talked about before. This use case links up to requirements 1, 5, 10, 200, so on and so forth, right? What is being actually done here? And then you can go back and see, hey, do we have a use case that is tied to no requirements? If so, why is it here? Again, do that whole process of checking to make sure everything makes sense. So traceability, also known as cross-referencing. And then we could have another line here for preconditions. So what has to have happened before this particular use case is allowed to run? Okay, so use cases or preconditions, basically, if I want to buy an item, well, that can't happen until the cashier is logged in, otherwise the system won't work. You look at this diagram, you don't get that information. There's no sequence of events happening here. But if you look at the description, okay, now it makes sense. Again, it's just the level of detail that you're looking at here. Now you can also order your descriptions as well. This is optional, right? So you have a nice little prose description here. You might also enumerate things. And this can help with removing any ambiguity in what you're looking for. So instead of a little paragraph, which might be hard to read, little enumerated bullet points here, or little list items, right? Customer arrives at checkout with items, cashier records it and collects payment. On completion, customer leaves. So hopefully this is kind of the detail that you would expect to have. And when to use this, we'll just kind of leave off here. Again, it's always kind of a good idea to use use cases, whether it's part of the formal process or not in your environment. Requirements is very, very difficult. I didn't give you the exam question. Why is it the hardest? But this can really help you figure out which requirements you need. Depending on your process, maybe you're kind of stuck. Okay, what is our point of sale system actually going to do? Let's take that example, right? We are creating a very nifty Apple iPad, those nifty little square or, iPad interfaces for buying stuff where you click buy, you swipe your card over it, click the percent for the tip, sign with your finger, and then you move on. You could model that out as use cases and then distill it into requirements, or vice versa. You have requirements, you model it out as use cases, and then you realize you have a big gaping hole because let's say you forgot about refunds. You forgot about linking up with your ERP inventory system, whatever it's going to be. But you will all be doing this for your projects. Hopefully that will help you figure out exactly what you're going to be doing, and that's your part of your next assignment. Anyway, that is it for class today. Any questions, comments, or concerns, feel free to visit office hours here in a moment. Again, if you joined late, no class Wednesday. That is our break day, and I will see you all on Friday. So goodbye, everybody. Have a wonderful Monday. Looks like it is a beautiful Monday outside. So have a good one. See you later.